uh, Practical Paper 2023, uh, 2023 paper, Practical Skills. One of the most important papers in Edexcel. Um, a student is given three solid compounds A, B, and C. Each solid contains one cation and one anion. Two of the cations are known to be sodiums and potassium. So what can we say is that they are saying it, right? Sodium and potassium. So the other one is not given. The student carries out flame test to separate the samples of each solid to identify each cations in each. Describe the method for carrying out the flame test. So basically, what are the steps? You got to initially write 3 points, right? The 3 points are what? You have to mention about using nichrome, platinum, or platinum wire, the inert metal, right? Use of a Then distillate it. Yes, you can change the order. So in your answer, you must mention not just the wire, the what type of a wire. You have to write the element, right? Inner element. So nichrome, platinum, or either nichrome or platinum wire you can use for this. You should mention in your answer. It must be mentioned. And the other thing is concentrated hydrochloric acid. Use of concentrated HCl. So with this only we are going to clean it, right? And the flame test, right? So if you had any cations there, so then you are carrying out the flame test, right? The methods of flame test, right? Method means basically what you do is you dip it with the solution and uh, take it near to the flame, right? If this is the flame, Bunsen burner flame, you dipped platinum wire is like this, right? You if you see the change of the color of the chain, then you have a metal. So based on the color, you can decide on the element. Right? So most important thing is mentioning the name of the platinum wire, the element it is made of, and the other thing is cleaning with concentrated HCl. Uh, you are using concentrated HCl to get rid of all the ions or impurities. Otherwise, it may give you false positive results. Then you are doing your frame test. Right. Because you are using concentrated HCl, there could be some on the wire itself, there could be some, what do you say, some depositions of ions, right? Salt ions could be there, some depositions. To dissolve it, you need a concentrated solution, right? Concentrated acidic solution. Complete the table with the results. A compound flame color. What are the colors? These are bread and butter, yes? If it is sodium, what is the color? O level stuff actually. Yeah, it's like yellow. No one forgets it. And this is lilac. Lilac or pale purple color, right? Lilac is a technical term. Lilac, a shade in purple color. And a pale green color. Pale green color is what? Pale green color is for, yeah, barium 2 plus. Yes. Apple green. Apple green for what? Yes, apple green for copper. So if you write it as copper 2 plus, it's wrong. It's not pale green. You call it as apple green. Keep that in mind. For copper, writing as copper, you don't get marks. For copper, blue green. Uh, I would use apple green. Uh, Blue green and apple green is kind of okay, but because in some my marking scheme, some years they may tolerate it, right? So I would call it apple green. Apple green is usually the trademark color. It's a different shade, right? Apple green, just like lilac. The student prepared separate solution of A, B, C using distilled water and then added dilute nitric acid followed by aqueous silver nitrate to each solution. A precipitate formed in all three mixtures. Solution of ABC. So is it just continuation of the same thing? Same thing, I guess. Distilled water and then add a dilute nitric acid. Uh, yeah, so here we have what barium 2 plus. So even without reading further, I could say if they're talking about making a precipitate because sodium is a what group 1 metallic alkaline metal. So they are not getting precipitate with a anion that we are discussing. So group 1 positive ions are not getting precipitate with any anions. Um, so therefore the only group 2 one is what barium 2 plus. So I feel like they are going to make a white color precipitate out of barium 2 plus. It is with what? Sulfate 2 ions, right? Barium sulfate. I feel like they are going to make a precipitate of this barium sulfate. Let's see. Nitric acid, aqueous, they are silver nitrate. First distill water, then and then added dilute nitric acid followed by the silver nitrate. If they add in silver nitrate, silver chloride, silver bromide, silver iodide, those are anions. Identify the name of the formula, three anions that could be present. Right. Precipitate is mixed, is made. So it means cations are what? Cations they have given it as barium, sodium, and potassium, and they are trying to identify the cations has been identified with the flame test. Right now they are trying to identify the anion. So it could be what a halogen, right? Group 7 halogen with silver nitrate. You can get silver chloride, silver bromide, or silver iodide. Right? Silver chloride is what white color. Silver bromide is what a cream color. Silver iodide is what a yellow color, right? And they are asking to write the name, right? Write the formula: silver chloride, silver bromide, silver iodide. Okay, they are asking about anion. So your answer must be written as chloride, bromide, iodide, right? They are asking the anion. So the anion must be the answer: chloride, bromide, and iodide. If you write it as this is the precipitate form. This is wrong, right? They are asking about the three anions. Okay. Compound B, A, B, C each contains different anions. Describe the chemical test on the precipitates formed that could be used to confirm, double confirm, right? Describe the chemical test on the precipitate form that could be used to confirm which anion was present in each compound. Give the results in each test. So now the precipitates are obtained, right? You have the precipitate of silver iodide, silver bromide, silver chloride. Now to further confirm, double confirm. Now with the color we can identify it, right? But after that you can have another step to double confirm it. What is the other step? Yeah. First you are adding dilute ammonia. in the presence of dilute ammonia. A little bit of ammonia, if it is getting precipitated, it is definitely silver chloride. And you adding dilute ammonia, and in the between the remaining two, so you identify it, you're putting silver chloride, dilute ammonia to all three test tubes, A, B, and C precipitates. A, B, and C. You add in dilute ammonia to all three, right? Uh, okay. In one of these, the precipitate is getting dissolved. Let's say it is A, we don't know, dissolved. Other two, the precipitate is not getting dissolved with the dilute ammonia. So then we know what got precipitated was what? The chloride ion, silver chloride ion. So it had chloride and ion. The remaining two, so let's say it was A, we don't know actually, right? Let's assume it was A, and A contained chloride and ion. The remaining two, either of them could be having B and C, are the remaining two anions. In that case, Br minus and I minus, right? So what you do at the second step, to the remaining test tubes, we are adding excess ammonia or concentrated ammonia. Excess means when you add them in excess, it is getting concentrated, either excess ammonia or concentrated ammonia. When you are adding concentrated ammonia, right, in the next step, right, one of these precipitates are getting dissolved. The ones getting dissolved is what? Is the anion containing bromide. Bromide precipitate. So silver bromide precipitate is getting dissolved in the presence of excess ammonia or concentrated ammonia. Remaining one, we know now the remaining one should be silver iodide. No? To double confirm, we are adding what? The remaining one is not getting dissolved, right? Even in the presence of excess ammonia or concentrated ammonia, remaining one is not getting dissolved, right? With the colors, we can identify them, but that is not enough to double confirm. You are going another step further. The the other step is addition of dilute ammonia. In the presence of dilute ammonia, out of these three only, uh, one precipitate is getting dissolved, that is the precipitate containing chloride and ion. To the remaining, you add in excess of concentrated ammonia. Between these two, one of these precipitates are getting dissolved in the presence of concentrated ammonia. That one is the precipitate containing bromide. The one is not getting precipitated even in the presence of concentrated or dilute is the anion containing I minus. Okay, right. So you must write all these things in few lines, 4 lines, right? Okay, very easy stuff, right? I would call this O level stuff. Just your memory. Same things are being repeated in the papers, practical papers. These are bread and butter. There's not much to give you in the exam, right? Edexcel content is like not much, right? There, Cambridge people at least they have their practical paper, but you guys don't have practical paper, right? They are just asking the basic stuff, this O level stuff. I would say the molecule, the molar volume of carbon dioxide may be determined using the reaction between calcium carbonate and ethanoic acid. The equation for this reaction is shown, right? The molar volume of carbon dioxide. They are trying to identify the molar volume. Molar volume means what? The amount of volume per 1 mole of gas. Right? Basically, what they're trying to do is they are going to collect this carbon dioxide, right, in a measuring cylinder or in a syringe. So they are collecting the volume, and they can find the amount of carbon dioxide released with the known mass of calcium carbonate, with the known mass of calcium carbonate. If they assume it to be 100% pure, or if they know the purity, they can find the number of moles of calcium carbonate used, or if they know the concentration of ethanoic acid, with that also you can identify, calculate the number of moles of ethanoic acid used. If you know the moles of ethanoic acid, basically they know the amount of moles of carbon dioxide released. So if you know the moles, if you know the volume from by measuring the volume released from the experiment. Experimental measurement is the volume of carbon dioxide. That's the observation. Volume over number of moles is what? Molar volume, right? At the given temperature pressure conditions. So let's say it is at room temperature and pressure, then you must get something around what? 22.4 cubic moles per decimeter value, right? If it is done under room temperature. Now, if they have done a perfect experiment, we don't know, no, whether they, because we haven't done this experiment. They are the ones who are doing it. With their measurements only, we calculate it. And maybe their values are containing an error. But I told you at room temperature and pressure, right? If they have done it in a different room temperature and pressure, their molar volume is different things. Because we can't take the responsibility of the experiment they have done, right? You can get any value, right? Assuming they have done a good job, then it should be 24 something cubic decimeters per 1 mole of gas. And it even that contains a lot of assumptions, right? We assume this to be ideal gases, carbon dioxide, an ideal gas, but there are no ideal gases, right? Okay, we are assuming that to be an ideal gas. Um, this is real gas, right? There are some kind of polarity between them, London dispersion forces, right? Okay, same things are being asked in the paper, practical paper. Place 30 cubic centimeters of 1 moles per decimeter ethanoic acid in boiling tube, but concentration is given. So here's the catch: if you have the correct amount of practice, you can get the what they are trying to figure it out. So they have given the concentration and the volume, C1 V1, right? So with this, there you can find the amount of ethanoic acid used. This is my way of doing it. In 1000 cubic decimeters, you have 1 moles, and they have used 30 cubic centimeters. With this, you can find the amount of ethanoic acid they have used. Directly proportional to carbon dioxide, half of this is equal to the amount of carbon dioxide released. In one step, you know what they're trying to do. The harder part is they ask you to find the errors in their steps. That thing is kind of trickier because you guys don't have the practical knowledge now. You guys are not doing practicals now, right? Right. The step up an apparatus to collect the carbon dioxide. Set up an apparatus to collect carbon dioxide produced over the water. Over the water, it is collected using a measuring cylinder. Very interesting practicals these are actually. If you are doing it in the labs, you have a measuring cylinder. This is the beaker. This is the exhaust gas released, and you can collect it over water, right? In a measuring cylinder. You guys don't do it, Cambridge people, they do it, right? Place approximately zero point 0.1 calcium carbonate powder in a clear, dry weighing bottle. There's a bit of thing, but we can assume it is excess, right? Yeah, they have a physical practical, but they have to do it. Their practical paper number two, paper number one is an MCQ. Just imagine, right? There are 40 MCQs to answer within 1 hour and 15 minutes. That's kind of tricky. They are the ace paper. So that's first paper. Second paper, Uh, they have structured paper, uh, 1 hour structured paper, structured essay paper. Usually 4 or 5 questions are given. The third one is the practical paper, 2 hour paper. They are usually getting 3 experiments, right? And they got to do it. And the first one is a titration, so you have to run 3 trials in titrations, right? The second one is usually on the enthalpy practical. Third one is anion and cation identification. In 2 hours, they could record it and do the calculations. So what we advise them is to within 1 hour take the measurements, and the next hour they can do the calculation and send the answers. And as the chief examiners, we are also doing the practical with them in parallel. So it's actually unlike Edexcel, it's kind of like lot of it's done under a lot of scrutiny, right? Because yeah, a lot of confidential process is involved, and you got to have a sophisticated lab, a sufficient enough lab to have a practical paper. Usually in India, they don't have Edexcel. They have Edexcel, but not that popular among students. It is Cambridge. So yeah, but there's only a slight difference between Edexcel and Cambridge. Usually in Cambridge they ask most of the theory part, theory-wise questions. Here you don't have the practical paper, but mostly it's research-based questions. So I like Edexcel in a way because of the way questions are asked. Kind of like like 70% theory, 30% think and write. Okay, especially biology. Nothing to memorize much. Yes. So, but Cambridge is different. Like, it's kind of like wild, hardcore, raw knowledge means facts, right? The memory. Yeah, there's a small catch. Zero point 0.1 grams of calcium carbonate is given here. So I assume it is the limiting. The limiting one is ethanoic acid. This must be in excess, right? Because when you calculate it, the molar mass of calcium carbonate is 100. So when it comes to number of moles of calcium carbonate, so you have to decide on that too. So maybe ethanoic acid is a limiting one, maybe calcium carbonate is a limiting one. Right? When you divide by 100, you are getting the moles of 0.01 moles. Right? Here we get a very little amount, right? 30, yes. So the limiting one is ethanoic acid. Yes, usually a calcium carbonate is not pure, so therefore no one knows the actual amount of moles of calcium carbonate. With the weight, you can't decide on the number of moles of calcium carbonate. Other For that you should know the purity. Usually in the container it is mentioned weight wise, WOW percentage wise calcium carbonate purity. Based on that you can calculate, right? So calcium carbonate is in excess. So when you're going through a paper, you must write them. Excess. Usually in the practical papers for Cambridge students, we tell these things. They are well seasoned when it comes to practicals, right? Okay, because they have to do about we season them with about 15-20 practicals before the exams, right? Weigh the weighing bottle and its contents accurately, right? So usually you do the measurement with the weighing bottle when you're doing a practical. You tear it and you put the weighing bottle, you get the initial weight, and with the weighing bottle on the scale itself, we are putting the adding some compound, and we take the measurement from the difference between the final and the initial. You can get the amount of mass transferred, right? Weighing bottle and its concept accurately. So you must tear it first, right, with the container kept on the measuring or the weighing scale. Remove the bung from the boiling tube and the tip of the calcium carbonate into the remove the bung from the boiling tube and the tip the calcium carbonate into the boiling tube. Uh, Quickly replace the bung in the boiling tube, right? So you have the boiling tube. What they are basically doing is you have the bung, you have it, the lid of the bung, you have to remove it and dip the calcium carbonate into the boiling tube. Then you put the calcium carbonate and quickly replace it. Why do you quickly replace it? Because by the time the different some yes sometimes actually leaking, but you have to be quick enough because otherwise you are not getting an accurate reading, right? Because remember now in the Cambridge student they must do this practical and collect the carbon dioxide gas released. So this time, last time, the last exam we had with them, May June exam, they had the practical like this, right? Just imagine. The uh, the second practical was something similar to this, right? So they had to collect the was not carbon dioxide as I remember. It was hydrogen gas. Something. Same steps. So otherwise it would be too late. When the reaction is finished, the measure the volume of a gas collected in the measuring cylinder. Then you have to, it's a very nice, interesting stuff actually, right? When you are doing it, you start liking the chemistry more, right? You are measuring the amount of volume of gas collected. Remember, even in Edexcel, there's a practical version. Though you guys are not doing it, there's a practical version. But yeah, nowhere. I mean, majority of the places, Edexcel practical paper is not done. Right? Because the cafe Edexcel is famous for its convenience. Because to have that practical paper, the schools they need to get prepared. They have to train the teachers. So it's kind of like messy, and it's a huge responsibility. Right? From the school side, it's a very huge responsibility, very confidential. So other than going through that hard, difficult process, schools always decide on going through the easier path. Even for students also, it's kind of easier because. But I prefer if someone is planning on moving in chemistry field, doing Cambridge is going to be very advantageous for them. They are planning on science work, science faculty. So I don't think like in Sri Lanka, like no one wants to get into field of science other than medicine, engineering, or other something else, right? Anyways, so when the reaction is finished, measure the volume of gas collected in the measuring cylinder. Done. Pre-weigh the weighing bottle. Pre-weigh the weighing bottle means so with that you can calculate the weight difference, right? Repeat the experiment 5 more times to increase the mass of calcium carbonate by about zero point 0.5 each time. Do not exceed zero point 0.4. What it means is calcium carbonate is the limiting factor here, right? So why? When the amount of calcium carbonate is increased, the amount of carbon dioxide is also getting more and more collected. So in this case, calcium carbonate is the limiting factor, right? Okay. So that is why they are measuring the how much amount of carbon dioxide is right. Okay. Let's see. So this is the procedure they have given. Maybe there are some errors in the procedure. Let's see. So anyway, their procedures are faulty. Draw a diagram of the apparatus used to carry out the reaction and collect the carbon dioxide produced over the water in 100 cubic centimeters measuring cylinder. Do not show the stands or clamps. There can be errors, right? In the procedure, there can be errors. So let's see. Because they are doing many things. They are weighing the amount of uh, calcium carbonate used. They are measuring the volume collected of carbon dioxide. They have given the concentration of uh, acid they have used. So let's see. Draw a diagram of the apparatus used to carry out the reaction and collect the carbon dioxide produced over the water. The measure. It's a very easy one, right? So you have the right. Here we have this one, the exhaust. Where is the diagram? Here you have the measuring cylinder. Here is water, and this is how it is collected. It is done on a water bath. Here you have the stand. It is on a tripod. Here you have the Bunsen burner. So you can just label them. Inside you have the contents, calcium carbonate. And here the gases are bubbled and getting collected. Simple little diagram like this. Do not show the stands or clamps. But you must have the tripod. I prefer using a tripod. Clamps means, so you can't place it like that. You have to clamp them, right? Yeah. When you're actually doing a practical, you must clamp it. Otherwise, you can't set it up. Even the beaker measuring cylinder must be clamped, right? When you are doing the practical, it is different, right? So usually we don't sketch these clamps to place the measuring cylinder upright and keep the exposed tube in place, and also this one also even another clamp. They ask you not to draw it, right? Do not show the stamps and clamps. The thing is, if you have it, your diagram may not look clear, right? That's the reason, because you will have to have clamps everywhere. But if your diagram is not clear because of the clamp, then you will lose marks, right? That's what. Okay. And other thing is, you must place this test tube. If you are doing a great job, you must place it up. It must be below. Measuring cylinder must be below, right? Test tube must be up. Why? Otherwise, what will happen? This water will come back through this tube into the tube. It will come back. Did you understand it? If you have the measuring cylinder above the test tube, boiling tube, this water will come through this tube into the boiling tube. Understood? So this must be placed much below than this. Got it? Did you understand my point? This must be placed low. Measuring cylinder must be placed low compared to boiling tube. Otherwise, the water will come through this and come inside the boiling tube. Explain why ethanoic acid is used and not hydrochloric acid. Very creative answer. What do you think? Why? If you use hydrochloric acid too strong, this is weak acid. If you add it hydrochloric acid, what will happen? By the time you close the pump, many would have gone out before you close it. Many carbon dioxide would have got released. So there is going to be a huge error in your answer. But when you have ethanoic acid, you have enough time to close it. A little bit of carbon dioxide will go out, but that's going to be infinitesimal, right? So that is why you are not using concentrated hydrochloric acid. 3 points, right? Mentioning which is stronger, which is weaker, and the reason. So not much of gas will not be lost by the time you close the bunk. A student suggested that mass of calcium carbonate could be measured by weighing the weighing bottle empty, and when the and when containing the solid. Give a reason why the method described in step 4 and 7 is preferred. So that suggested that mass of the uh, give a reason why method described in 4 and 7. Let's say 4 and 7. Let's have it like few more, like 4:30. We'll try. Place approximately. So now here, when you look at step 4, 3 and 4, right? Right. So that now they have actually right. Why they have measured calcium carbonate, right? Uh, Now they have approximated the mass of calcium carbonate before placing calcium carbonate. As you can see here, they have approximated a certain amount of calcium carbonate and they have put it on the weighing balance, right? Now what they're saying is they could have measured the empty weighing container and then add the calcium carbonate and measure the weight difference, right? And with that they can measure the amount of calcium carbonate used, right? But they have not done something like that, right? And step, but they have not done something like that. They have added the contents into the weighing the container, and they have taken the mass, right? What is the reason is you don't need to measure the amount of calcium carbonate added into the container, right? Because as it seems, calcium carbonate is the what? Right. Okay. So as it seems, right? Calcium carbonate is a limiting reagent, right? Calcium carbonate is a limiting reagent. So we don't need to know the amount of calcium carbonate added. We only need to know what? The amount of calcium carbonate reacted, right? So we can think like this. We can think all the calcium carbonate added is has completely been reacted. But it could not be the case. There can be some remaining calcium carbonate. We feel like reaction is over. Why at the later part of the reaction is happening very slowly, right? We don't have the patience, but still the reaction is going on very slowly. The later part of the reaction is happening very slowly. So we may think the reaction is over, so we can assume all the contents we have added into the container is over. And we think, right, the weight difference we have taken, right? As they say, the weight difference they have taken earlier is equal to the amount of calcium carbonate reacted, right? But the case is if there are some calcium carbonate remaining in the solution unknowingly, Reaction is happening slowly yet. We don't know whether it is completely reacted or not. We may feel like reaction is over, but still it is happening slowly. So therefore, to avoid that error, what they have done here is they don't mind the reaction is whether finished or not completely. As long as they are taking the weight difference, they know exactly amount of calcium carbonate reacted. So they have taken the container, put the contents in, and they take the initial measurement. They have done the experiment, and when they feel like it is over, they have taken it and again taken the weight. Let's say W2 and here W1. W2 minus W1 is equal to the amount of the weight difference. The weight difference is equal to the amount of calcium carbonate reacted. Simple as that. Okay, otherwise, if you try to uh, measure the amount of calcium carbonate that has been added in and assuming calcium carbonate has been completely reacted, there could be error. Right? There's no way to know whether it has been completely reacted or not. Because at the later part of the experiment, it is happening very slowly. Now here, we don't mind whether the reaction is over or not. If when we feel like reaction is over, we take the weight difference and we assume that difference in weight is equal to the amount of calcium carbonate reacted. Okay, right. So give a reason. There's only one. So you have to understand many things by analyzing the steps. Uh, and write in one word. How do you write? The reason is, right, there could be some calcium carbonate left in the weighing bottle. In the weighing bottle, right? Okay. There could be some calcium carbonate left in the weighing bottle. Left in the weighing bottle means even after reaction is over, or reaction is over, we feel like reaction is over, but still calcium carbonate has not been completely reacted. There's a bit of pinch of calcium carbonate is there. With this method, even that pinch of calcium carbonate can be considered and get the accurate reading of the calcium carbonate reacted. Right? So just want to tell the examiner we have understood the point. So when they go through it, they know okay, he has got the point. There could be some calcium carbonate left in the bottle. Left in the bottle means after the reaction. Or by the time we stop the reaction, there could be some calcium carbonate remaining. Understood? All good. The result of the experiment are shown. Mass of calcium carbonate, volume of carbon dioxide. They are plotted in the graph. So seems like mass is proportional to calcium carbon dioxide reacted. Plot the data on the grid. What sort of you must get a what? With the mass, it must be directly proportional, right? And when you are plotting the graph, this is very important. At least 50%, at least 50% of the two axes, at least 50% must be marked. 50% means your data must be occupying at least 50% of this axis. For example, you sketch the graph, your data points are like here and here. Your answer is wrong. It should be spread out. So you must pick a scale. At least 50% of this axis must be marked, right? So something like this, spread out. So values will be spread out. You are picking the right scale, right? Understood? Otherwise, your data is around here, inaccurate. The more spread the data is, more accurate, percentage wise, more accurate. Percentage error is less. Right? It should be spreaded out. Right? I am talking about both x and y axis. Is it clear? Right. You must label the scales, write the figures, at least 50% must be occupied of the axis. 50% at least your values must be up to mark here from the beginning, right? At least up to here must be marked. At least. So it is the directly proportional, right? And your line must go through maximum points. If it is not going through maximum points, at least it must go through what? If it is going these values, it must go directly dividing the data points scattered. Right? You must exactly divide the scattered data point equal into two sides. Or you should pick a line, uh, the line that goes through many number of data points, right? And here it must go through what? 0, 0 point. So y equals mx type of graph. So if the data points are correct, it must go through the origin. The data points are correct, but we don't know whether data points are correct. So your line may go a bit deviated from the origin, right? Depends on the data points. The data points are rather off, it will not go through the origin, right? But do not sketch your line through the origin, because if you are sending the line through the origin, you are manipulating your results. You can't manipulate, right? You are cheating in that case. It should go through the origin, but if you are sending through origin by force, you are manipulating your results. So you can pick a line and go. If it is not going to the data point, that is okay, because you are not the one who is not taking the data. That's a measurement error, right? If you are the one who's doing the practical, then if your line is not going through the origin, then you should be afraid. Here, no. Your job is to mark the points and draw a reasonable line. Whether it is going to the origin or not, it is not up to you. That is to the person who has taken the data. Is it understood? Right. So seems like now let's assume that it is the data points are okay. Then usually they give you data points that goes to the origin. That is also point. Usually in every marking scheme I have tested, and all the graph I have tested at your level. Most of the time, if it should go through the origin, it is going to the origin. So yeah. So in that case, by looking at the data points, right, try to draw a line that is going through the origin, because most of the time they give you points to sketch you a line that goes through the origin, and in this case also you must get something that is going through the origin. Okay, right. So this best fit line is going to the origin. Use the graph to determine the volume of carbon dioxide formed when 0.25 grams of calcium carbonate is used. This is a calibration plot. 3,500. Yes, so now you have the graph. So you draw a vertical line. Let's say this axis says what? This says 0.25. You mark point. So let's say in your graph, let's say it is 0.25. I don't know. You draw a vertical line from here, right? Using a ruler and your triangle. You can do a better job with that in your instrument box. Take your instrument box with you, and from the point it intersects, draw a horizontal line from the when the point, this horizontal line cuts the vertical axis with the volume respective to the amount of gas released for the given mass of calcium carbonate. Right. You must show your working. So your working must be something like this. Straight lines, right? Straighter lines. Calculate the value of molar volume of carbon dioxide using the volume from D2 and the equation for the reaction. So whatever the volume you got, and so the mass is, it is 0.25 they have mentioned, 0.25 grams, 0.25 divided by molar mass of calcium carbonate, it's 100, right? Right. 100, and then half of this value is equal to the amount of carbon dioxide moles released. Why? Is 2 to 1 ratio. See, there is it. The ratio is 2 to 1. 2 to, no, 1 to 1, right? No need to divide. Calcium carbonate to carbon dioxide is 1 to 1 ratio. Easy. So if you know the mass of carbon dioxide released and the amount of carbon dioxide calcium carbonate used and the amount of carbon dioxide released, see, volume from the graph, this value is given 0.2. So remember, you have to calculate the molar volume based on this part 2, right? You can find the molar volume from any other place of the graph or from the initial data given, but they have asked you strictly to find the molar volume from second part of the question. So use the volume you have obtained here and the number of moles of calcium carbonate you have calculated to find the molar volume, right? Okay, so what's the molar volume you got? From the volume you have obtained from the part 2 and the amount of carbon, number of moles of calcium carbonate must be from the part 2, they have mentioned 0.25. What's the value you got? Yeah. What is the answer? Molar volume. Molar volume. They are asking to find the molar volume. Yeah. The molar volume you got. This is A, B, C, D. 20. Yeah, 22 something is, if you get a something, a value around that. So that is closer to real value, right? 22. Uh, right. 22.4, 21. Yeah, question. Right. 21, 21.021, right? That's the ideal value, right? Okay. Yeah, 21.021. That's the ideal answer. 21.021. But it depends on the value you have obtained, error carry forward. Right? It depends on the value you have obtained in the part, the previous parts. Right? So ideally, you must get a value around 21.021 cubic decimeters per mole. Okay. So remember, when you're plotting the graph, also use the cubic centimeters, right? Grams and cubic centimeters, not any other units. If you use different unit, you will lose marks, right? Grams to cubic centimeter. That must be the correct units, right? Give two reasons why the molar volume obtained by this method is lower than the data booklet value. Yes. Another thing is, how do you know whether it is 100% pure calcium? There can be impurities. So we assume it to be 100% pure, 100% if the calcium carbonate, because you can't find 100% pure calcium carbonate if the calcium carbonate is not 100% pure. It means calcium carbonate number of moles are less. So therefore, you are getting low volume of carbon dioxide released. But we assume this calcium carbonate is having what? Greater, yeah, you assume it to have a more, yeah, 100% pure, so you assume it to have more calcium carbonate moles. So volume is actually, you are gathering is lesser value, but greater number of moles. Volume divided by number of moles. So number of volumes are greater, volume is less. So you are getting a lesser molar volume. Right? And if your method is getting low value, right? So that means you may get a lower value, right? Another thing is, as you said, carbon dioxide is released. So therefore, still the volume collected is going to get less. The number of moles we assume is going to be the same. So again, molar volume is going to get be a lower value. Other one is what you said. Yeah, escaping, and other thing is very good. Carbon dioxide is can be getting dissolved, so therefore still volume is decreasing. So you can write three things, 3 points clearly. Out of these three, if you write two things, you are getting full marks. Short and sweet. Right. Uh, but I prefer not to use the purity of calcium carbonate. Why? Because we are checking the weight difference. So even though calcium carbonate is not pure, that's a very good point. Even the calcium carbonate is not pure, we don't mind because we are find the weight difference. What is being reacted is actually 100% calcium carbonate, and that's a very good point. So you don't need to mind about calcium carbonate impurity. If you write the calcium carbonate purity, you are losing marks. A very good point, right? This experiment, in this experiment, calcium carbonate purity, it does not affect. Why? We are finding the weight difference. Where the decreasing weight is definitely calcium carbonate, 100% calcium carbonate. Okay, so you have only 2 points, not the purity of calcium carbonate. One thing is gas escaping, other one is carbon dioxide is getting dissolved. Right, it's a very good one. Okay, so I'll end the class for today, and we have one more to discuss. So these practical questions are very interesting, right? Other than theories. Okay. We have one more in organic chemistry. We'll continue discussion after it. Right? We'll have another class, the A2s, in the later, right? Take care. Bye bye.